The seacoast of Maine, an icon of New England beauty. But the ocean water here is growing warmer and at an astonishing speed. What will it take to discover the reason why? Today, off the coast of Maine, oceanographer Charles Tilburg and his students are searching for clues to a scientific mystery. Throughout all the world's oceans, the temperature of the water has been rising. But in this part of the Atlantic, known as the Gulf of Maine, it's been rising 3 times faster than almost any other place.
The question that I'm asking is, why is the Gulf of Maine warming at such an alarming, accelerating rate?
It's still sucking down heat from the atmosphere.
To find answers, like any scientist, Charles begins by gathering data. In particular, data about the form of energy that makes anything become warmer: heat. Like other kinds of energy, such as light, heat moves from one place to another, and it can be measured.
What scientists are really interested in is the amount of heat that the ocean is absorbing and the amount of heat that the ocean has in it.
Over the past century, all of the world's oceans have been absorbing increasing amounts of heat. Because the huge amounts of carbon dioxide and other greenhouse gases we've been releasing have been holding more of the sun's heat in the atmosphere. And most of that heat makes its way from the air into the ocean because water has a much greater capacity to store heat.
The ocean absorbs 80 to 90% of all of the heat that humans have put into the atmosphere due to greenhouse gases.
But why is the seawater in this particular spot warming so much faster than almost any place else?
The water's warm there.
To answer that question, Charles and his students, Lydia Pennard and Andy Robinson, are taking on an ambitious project, calculating how the total amount of heat in the Gulf, what's called its heat content, has been changing over time.
The heat content is important because temperature can fluctuate on a daily basis, on a seasonal basis. It can fluctuate for many different reasons. And that's one of the things that people will sometimes brush off in terms of climate change of, oh, this temperature's only changing today. But heat content can be used to determine the larger scale impact, which is a really important indicator for climate change.
To gather the data they need to calculate heat content, the team uses this submersible sensor. As it descends, it records the water's temperature and also its salinity, how salty it is. Information that helps in tracking the movement of heat, because the saltier the water, the more quickly it will warm. Measuring the changing quantity of heat in the Gulf is just one part of the project. The team also wants to figure out where the heat is coming from. While they know a lot of it comes from the atmosphere, they suspect that some of the heat is coming from rivers that flow into the Gulf. Rivers whose water is warmer than ocean water. But to better understand the influence of that river water, they need to track its movement through the Gulf.
If we could see if it is actually the river plume that the waters are mixing with.
That's what Andy Robinson is working on. And that's why he built these drifters. He mounted cheap GPS units onto plastic buckets. Total cost? $105 each.
We put these drifters in locations where we know relatively warm water is moving into the ocean. And then we let them go and we see where they end up.
Charles and his students are far from the only people collecting data about the Gulf. For example, a regional organization that includes scientists runs a network of automated buoys that measure temperature and salinity, data that anyone can download.
2017 and 2018 are both higher than 2012.
There's a lot to pour through, because in the Gulf of Maine, there is a lot going on.
In some places, it's going to get warmer because of the atmosphere. In other places, it's going to be because warmer water is moving in. In other places, it's going to be because colder water is not moving in. And the Gulf of Maine is this perfect storm of everything happening at the same time, all the different types of mechanisms. That's why scientists are so excited about it, because scientists can look at this and say, all right, this is the time where we can study all of these different mechanisms, how they interact with each other, and apply them to other places so that we can see what might happen in the future. And that's the question that I want to know the answer to.